Hey guys, for your warm-up today, I want you to open this GeoGebra website and I want you to click through all of the different options and I want you to play around with them and figure out what you notice about the cross sections for each one. Alright, once you are done with that, do that for about 8 to 10 minutes. Fill out the top portion of your notes. Pause the video until you finish that. Alright, so today we're going to talk about cross sections and solids of rotations. So for cross sections, it's if I were to cut this three-dimensional figure, what two-dimensional figure does it make? So if I were to cut a sphere through here, this would make a circle. If I were to cut a sphere this way, it would also make a circle. If I were to cut it this way, it would also create a circle. For a rectangular prism, if I cut it straight across through the middle, it would form a rectangle. If I cut it vertically, it would also create a rectangle. The one that is different is if I only cut part of this rectangle, it would form a triangle. Then we have triangular prism. If I were to cut it straight through the middle horizontally, it would form a triangle. If I were to cut it vertically, it would form a rectangle. For a cylinder, if I were to cut it horizontally, it would form a circle. If I were to cut it vertically, it would form a rectangle. If I were to cut a cone horizontally, it would form a circle. If I were to cut it vertically, it would form a triangle. Remember, if you have any questions, write them down. When I get back tomorrow, I can answer them for you. Alright, slicing 3D figures. When you slice a three-dimensional figure, the cross-section will be a two-dimensional plane figure. So square, circle, rectangle, triangle, rhombus, any of those. So for example, if we slice a cone parallel to the base, okay, so we have one right here in this picture. We have our cone and we sliced it parallel to our base. The cross-section result is this shaded part. That is a circle. Alright, so now on questions 1 through 10, I want you to go in and I want you to name all of those solids. So what is the name of that figure? This is what we had talked about on Friday, so refer back to those notes if you need to. Alright, so let's start with number 1. It says for each figure, name it, then draw a diagram of the cross-section formed by the intersecting plane. The intersecting plane is the shaded one on all of the figures. Okay, so number 1 is a cylinder. If I were to cut it right through here, this would form a circle. The reason we know that is it is parallel to your basis, so it would be the same shape as your base. Hey. Alright, number 2. River, sit down. Number 2 would be a rectangular pyramid. The reason it is a pyramid is it only has one base. And for our cross section here, it is parallel to the base, so it would have the same shape as your base, which is a rectangle. Alright, number 3. On this shape, we have a base with 6 sides. Oop, my bad. Since it has 6 sides, it is a hexagonal. And there are 2 bases. There's one on the top, and there's the one on the bottom. So this is a prism. Now we're looking at the cross section that is parallel to the bases. Since it is parallel to the bases, it is the same as the base. So this would be a hexagon. All right, number 4, we are looking at a triangular pyramid. Okay, so this one, it only has one base, this base here at the bottom, and it is in the shape of a triangle, so it's a triangular pyramid. For the cross section, it's intersecting parallel to the base, so it is the same shape as the base, which is a triangle. If you have any questions, write them down and let me know tomorrow. All right, number 5. This figure is a cone, but this time we are not cutting it parallel to the base. We are cutting it vertically up and down. So when we cut this vertically up and down, you look at the shape that it makes. So this cone makes the shape of a triangle if you were to cut it from the top to the bottom. All right, number 6. On number 6, we have 2 bases. We have our triangle here, and we have our triangle here. Since both of our bases are triangles, it is a triangular prism. Prism means it has 2 bases. Now here, when we're talking about the cross section, it is vertical to the bases. So when we cut this, it's not going to be a triangle. It's going to look like the side over here. So it's going to be a rectangle. All right, number 7, we have 2 bases. We have our base here, and we have the base in the back. Both of these are in the shape of a trapezoid, and there are 2 bases, so it's a trapezoidal prism. Now the cross section is parallel to the base, so it is in the shape of a trapezoid. Number 8 is a sphere. Its cross section, anywhere you cut a sphere, you're going to have a circle cross section. Number 9, we have 2 bases here. We have this front base and we have this back base. Both of these are a pentagon. So we have a pentagonal prism. Since it is a pentagonal prism, we need to look at our cross section, which is horizontal to the base. So when we draw our cross section, it's not going to look like the base. It's going to look like this bottom section, which is a rectangle. Number 10 is a cone. And this time, when we cut this cone, we are cutting it parallel to the base. Since it is parallel to the base, it has the same shape, which is a circle. All right, if you have any questions about the cross sections of 3D figures, make sure to make note and ask me tomorrow. Now, let's move into rotating 2-dimensional figures. So when you rotate a 2D plane figure, it becomes a solid of rotation. That solid of rotation makes a 3D solid. So over here, we have a rectangle, and it is rotated around this line. So we're rotating around the line. When we rotate this, it's going to follow the pattern I just drew in green. So this side will rotate. This side will rotate. When we rotate these, we get circular bases. And since it's a rectangle, we know that this edge will also be straight. So what figure does this look like? If you said a cylinder, that is correct. All right, let's look at a couple more. On number 1, we have a triangle here, and we want to rotate it about this line. So when we rotate, the bottom will rotate, ooh, that was not good, in a circular motion all the way around. But also, we have this side length, and if it's triangular on that side, we also know it's going to be a triangle on this side. So we have that circular base, and a triangle on top, which means this is a cone. Next we have number 2. Number 2 already looks like a semicircle, and we're rotating it about this line. So when we are rotating this semicircle, we're going to look at the middle portion, this line right here. We know this line is going to move in a circular motion. And since that part is circular and we have a curved edge, we also need to draw a curved edge on this side. There we go. And what shape does that make? If you said a sphere, you are correct. All right, number 4. On number 4, we have 2 triangles. With these 2 triangles, we're going to start with this section in the middle. When that moves, it's going to move in a circular motion around this line of rotation. And since the top part is a triangle, we know the other side will also have to be a triangle. Since the bottom part is a triangle, we also know the other side will need to be a triangle. But that doesn't look like a single figure that we have. So this is actually 2 figures together. This top figure is a cone, and this bottom figure is a cone. So here we have 2 cones stacked on top of each other. Now I want you to take a moment to try 5, 6, and 3, and then you can check your answers with the key when you're finished. Once you are finished with these 3 examples, you have some check your understanding questions on the next side. Go ahead and answer those. When you finish, watch the Math Shorts video in Google Classroom. When you finish that, you can either work on the quizzes or you can work on this portion of your Delta Math. I hope you have a great day, and I will see you all tomorrow.